Again, good morning, and for some folks who joining from the East Coast, good afternoon. And thank you guys for joining on Sunday, as always. I know it's tough for some folks who have families and kids, but again, we really appreciate your attendance. And I just would like to start today, class with a quick reminder that very soon, June 16th, literally in less than 10 days, we're going to start our comprehensive XCUITest bootcamp, which is a one-of-a-kind program. There is nothing like this exist online because this is more advanced and in-depth program for those people who would like to make a next step and move from manual testers, or I would say mid-level automation engineers or web automation engineers, to the what they call SDET, which is the highest role in the quality field, software developer engineering test, focusing on mobile. And this is a great bootcamp because it's a product of our 2 years work for this particular program. And we incorporate all the cool stuff from our existing jobs, from our consulting into this bootcamp. So it's never repeat itself. It's super up to date with the latest and greatest tips and tricks of how to build enterprise level solutions. We cover topics that nobody cover online, and that solves the problem that actually are well demanded in the industry. And interesting fact that I spoke with our former student Natalia, and she was sharing her experience to go through interviews in Apple and Lyft and other bigger companies. And she was sharing with me the story, and I asked her to write a post in our Facebook group, and she did in Russian, actually, unfortunately. But for those who's Russian speaking, you can watch her post, and it's phenomenal that nowadays companies are paying I would say 200,000 and up in Silicon Valley for SDET roles, for simple one reason: because there's a lack of professional people right now in the industry, and there's a lot of companies who are hiring right now people for iOS native automation, for Android native automation directly. Top firms are looking for professionals, but they cannot find, they don't exist. So this course is actually for not for the beginners. We're not built for people who never done coding before, but it's definitely a great upgrade for those folks who just start coding or have some exposure and want to excel in their career. And another announcement I want to make that today, yesterday, I'm sorry, I was posting in a Slack channel that today we're going to focus on interview algorithm from Apple. And I would like to apologize in advance because after I posted, we spoke with Boris and look at the problems and realize you guys not ready yet. In order to cover a real deal problems, the coding challenges from bigger companies as Apple, as Google, we still have to cover few topics to prepare you for these problems. We don't want you to drop you in the middle of the ocean. We want you to actually build you a vessel so you can swim, and you need to still acquire some skills in order to understand those problems. And today Boris will focus on prerequisites for such coding challenges, and he's going to focus on the sorting, right? And next week's session we're going to focus on recursion. So before understanding these two fundamental I would say programming concepts, you won't be able to understand the coding challenges from top companies. So again, I'm apologizing for giving you false information, but this today's session and as well as the next week's session will be prerequisite, and then we will start dive into the real challenges that come from our former students, our friends who actually went through the top companies interviews. We're gonna show you what a company is actually demanding nowadays. Saying this, I will pass to Boris, and you guys have fun during today's session. Sorting is probably the most fundamental aspect. Boris?
Thank you, Igor. Absolutely. Sorting is very fundamental thing. Now, all computer science majors start algorithms from sorting, I would say. So sorting is an interesting problem because people, I mean, computer scientists, did not find an optimal solution yet. So there are a bunch of problems. All currently known solutions are not efficient. So they have some bad runtime complexity. And we'll take a look today. What does that mean? Let me share my screen. Great. Okay, so we're going to cover a few different sorting algorithms today. We're going to start from easiest one, of course. And then we will try to see what's the difference between those and why some are better than others. So probably you've heard about this already. Bubble sort is the easiest one, right? So let's start from that. Hopefully you see my screen. Let me create a new class. So, let's say sortings. We can create one class sortings, and then I'll add all the different sort algorithms here. Great. So what is the problem in sorting algorithms, first of all? We have an array. Usually we will take, for example, the array of integers, but you should understand, sorry, that basically there is no difference, right? The element inside doesn't really affect any algorithm itself. We do not care what to sort. If it is character, right? If we sort words, then every char has some unique code, and we can deal with that code as with integer. Same with any other data type. So it doesn't really matter what type is inside. So let's just take integer as a good example for that. We have some array. Let's say 100 minus 4, 5, 0, 10, and 6. The sorting result would be minus 4, 0, 5, 6, 10, 100, right? So this is a fundamental problem in computer science. A lot of use cases, real use cases in the programming can need the solution. Whenever you need to sort something, you need to use some sorting algorithm. Obviously, there is a built-in sorting algorithm in Java, right? So you can use arrays.sort if you need to sort it really in the progress of the coding. So basically, you probably will not implement your own sorting algorithm on the real work, but for the interview, chances are they will ask you to implement what is the arrays.sort inside, right? So we're going to implement today the algorithm that is basically used by this arrays.sort. Obviously, we're going to start from the easiest sorting, and real arrays.sort uses the most advanced one, which we will cover as well, but we need recursion for that. So we're going to do that a little bit later. Okay, again, we have an array. The real task is to sort this array in any order. We can use ascending order or vice versa, or descending, right? Let's do ascending. Doesn't really affect anything.
By the way, I just want to make one comment what Boris said, which is very interesting. During interview, whenever you present the issue that or problem that you need to sort something, always ask your interviewer, do you want them to, are they allowing you to use this built-in sort, or you have to build your own sort? Clarify this. If you're dealing with a complex problem where the sorting is just part of it, they might allow you to use a sort. because that's not the main problem or the solution that they're seeking for. In terms of if it's if the challenge itself focusing on the sorting, then make sure to clarify that you have to build the sort yourself, which the board is going to show you right now.
100% yes. Thank you, Igor. So double check that they are asking to implement sorting from the scratch. In our case, we are going to implement the sorting from the scratch because that's the topic of our lesson today. Great. So bubble sort. What is the input and what is the output of this problem? We can, so since we implement everything in Java, we probably can just do it in place because we are allowed to change the elements in Java array usually, what it's called in place without copying the array itself. So let's just use some void function for now that will take an array. So let's do bubble sort. The most famous sorting ever. I will show you a really cool video after this problem. I will send it in Slack. You'll like it. So a void function, we are not going to return anything, but we are going to wait an array as an argument, right? So we're going to wait an array and we're going just to sort it in place. So the same array will be sorted after this function returns. Great. So again, input is array of integer, output is void. Cool. So what data structures and metadata with it will be used? This is primitive sorting. So we are not going to use any data structures here, but we're going to use interesting combination of loops. Before we're doing that, obviously we will need to change the different elements with each other, right? So we have, let's say, 100 and -4. At some point, we are going to change them. So this index should contain -4. This index should contain 100, for example. So that's an interesting problem as well, separate problem. We should start from that. It's pretty easy. So how to do what we call swap. If we have an array and let's say it can be private, right? Because only those algorithms will use it. So the function swap takes integer array, takes two indexes, right? Let's say I and j. And the goal is to take this array and change the elements that are sitting on ith place with the j's place, right? Because our sorts, all sorts, will use this function pretty heavily. On the first side, you can think that it's very trivial problem, right? Because what do you mean? We have, let's say, a little bit different problem. We have two integers, and int x 5 and int y 10. How to change them in that way that x now becomes 10 and y now becomes 5. So just how to change two variables. Sorry, I need to admit somebody here. Yes, I admitted the person. So we have two integers. How to change the values to each other. And obviously you cannot do x equals y and y equals x, because once you assign y to x, the previous x is lost, right? So you will reassign x to y and both of them will be 10. Nothing will be 5 now. So the answer here is, I can draw it. let me draw it. Let's say you have, yeah, create third one variable, very good. Let's say you have 2 cups. One cup is with, let's say, water, and the second cup is with milk. How to change them so the left cup now contains milk and the right one contains water, right? You cannot just use 2 variables for that, because if you're going to basically move the water to the right cup, you will lose what was in right cup, right? There will be no milk anymore. So what is the answer here? You need to introduce the third cup, empty third cup. Now you can put the water in the third cup, put the milk in the left cup because it's empty now, all the water in the third one, and then put the water from third one to the right one. Very elegant solution. And you need to do this, you need to use it. So now, let's do the same thing with the variables. If you have X, you have Y, you can introduce what we call temp, that will be 5, that will be X. And now X is saved, so you can reassign something else to X. Let's say X equals Y and Y equals temp, which is the previous X. So this is an easiest way to change 2 variables. Now let's do same in our private swap function. So our swap function will introduce temp variable, temp because it's like temporary variable. And our temporary variable will be our array from, those are indexes, right? So array from I, let's say. Now array from I equals to array from J, because array is I saved now to the third variable, we don't need it. And array from J equals to I. Like that. That's it. This easy function will help us to do the permutation. Cool. Now, let's get back to our bubble sort. So we have the array. The idea of bubble sort is simple. Let's smoothly move from left to right and compare 2 neighbor integers, 2 neighbor elements. We know that our goal is to make them all in ascending order. So we can take a look on 2 neighbors, and if they are in the wrong order, so they are in descending order, just 2 of those, let's just swap them. Let's just make them into correct order. If we're going to do that, we're going to say that this is swapped, right? Oh, yeah, sorry. Sorry, thank you. Thank you for your attention. Array from J equals temporary, of course. Cool. So we are going to swap 2 neighbors, -400, and then 5, 0, 10, 6. Right? Obviously, this is not enough. Those 2 elements now are in the correct order, but everything else is not. So we should continue to do that. -4. Those 2 are not in the correct order as well. So let's swap them as well. 100, 0, 10, 6. Cool. That's better, but it's not enough again. So let's do again. 2 and 100 are not in good order. So 0, 100, 10, 6. Why it is called bubble? That's why. Because if you can see, this 100 is like a bubble. It's slowly moves to the top, right? So it was the first one, and then we swap it with the second one, then we swap it to the third, then we swap it to the fourth, then we swap it to the fifth. So basically this 100 just moves to the correct place, like a bubble. That's why it is bubble sort. Now, our 100 is finally on the correct place, but obviously it is not enough, right? Because even if it's 100 on the correct place, everything else is messed up, because let's say this pair is incorrect, right? So 5 and 0 are wrong. So we need to do this procedure multiple times. Basically, we need to do it until we can just go through the whole sequence and we will not find any pair that is wrong. So all individual pairs will be in ascending order. This will be an indicator that our bubble sort is done. This is the final one, right? Cool. So how to do that? How to do that? Let's say we have, let's start from the main action when we are going to go through all pairs and swap them. Yes, we definitely will need nested loop. Unfortunately, it is impossible to do bubble sort without nested loops. That's why it's not optimal, right? Let's start from the main action. Whenever we go through the sequence and find the incorrect pair, it's not that hard to do. So for int I from 1 to the length, y from 1, let's do from 0 right now, doesn't really matter. So we start from the beginning and we go through the whole sequence, and whenever we see that something is wrong, some pairs are wrong, we should swap them. So we can decide which neighbor are we checking, because let's say we are looking at the first one, we can compare it with the second one. In that case, we need to go not to the last one, but before the last one, right? Because we're going to check it with the right neighbor. So basically this one does not have right neighbor. So we should stop here because this guy is the last one who has the right neighbor. Otherwise, not say like also works, doesn't really matter which way to choose. We can start from the second one, and in that case, check the left neighbor. In that case, we can go to the end because the last element has the left neighbor. So let's start from the second element, which is I equals 1, and we will check every element with the left neighbor. Oops. So if array from I, so we are checking with left neighbor. In the good scenario, in ascending scenario, we should be greater than left neighbor, right? Because left neighbor is like should be smaller. So then we check if we are less than left neighbor, then something is wrong, right? We need to change something, swap things. So if we are less than left neighbor, then we're going to swap. We're going to say swap. We just reuse, we are reusing the private swap we just wrote here. So we're going to swap what? Swap array, and two indexes we are going to swap is I and I minus 1. Two neighbors, basically, right? Cool. That's the main action here, basically. So we just go through the whole sequence. If we detect the wrong order in the pair, we just swap those neighbors. In that case, this we should get this array in the end. It's still wrong. It's not sorted yet, right? Because this pair is wrong, right? And this pair is wrong. We have two pairs wrong. But our 100 is in the correct place right now as a bubble. Then how many times do we need to do that? To repeat this action, to do this again and again, check the pair, swap, check the pair, swap, until all pairs will be correct. If we go through the sequence and we cannot find any pair which is wrong, we can stop. So we can use while for that. While, because we are going to introduce a flag that we will mark here if we find any wrong pair. So until we did not find the pair, the wrong pair, we will assume everything is good, everything is sorted already. But once we find the wrong pair, we'll mark this flag and start once again. So let's introduce the Boolean flag, true as or let's name it needs like that, swap detected. So basically this indicates that if we detected one swap, we need to start once again, right? So swap detected will be true for now. And then while swap detected is true, we do this whole thing. But the idea is once we get into the while loop, we will assume that there is no swap anymore. So we will make swap detected to false. And only whenever we found the wrong pair, we say, okay, swap detected. Oops, swap detected is true now. If swap is detected, this while will go once again. Once swap detected is false, meaning we didn't find any pair when we moved into this nested if, then we didn't mark swap detected, then we can exit from our loop. That's it. So arrays should be sorted. Let's write some unit tests to double check it works as expected. Sortings tests. Okay, so let's double check sort, bubble sort. How to do that? We need to introduce the array. So array will be, let's just use our test array that we introduce here. And again, obviously we need to do right without any new, like that. Okay, so let's say this is our array. Let's just print this arrays to string array, just to see the, actually this is unit test, we don't need to do that. So we have the array and we are going to do expected result array, right? So expected result is sorted one, right? So -4, 0, 5, 6, 10, 100. This is expected result. So now we can use sortings. And just apply sortings dot bubble sort. No, should be public. Yes, bubble sort to array. That's it. And now you should assert that assert array equals basically expected result with the previous array. That's it. So this array will be sorted after the bubble sort will be applied to this array, and now it should be equal to our expected result. That's our unit test here. Let's just double check. Test passed. What is runtime complexity here? What is memory? Yes, time is n square, absolutely. N square. Big O from m square. Because we have 4 inside the while. So in the very worst case scenario, the worst case scenario will be the array is sorted into descending order, and you're going to resort it to ascending order. You will need to do exactly n square operations to do that, because you will do this n time. And in every iteration, you will go n time here. So n times n. What about memory? We didn't use anything here, right? So memory is constant. Memory is constant. We're going to see today one interesting sort that is vice versa. Great. So one more sorting. Square sorting as well. So the next one is, let's choose selection sort, for example. The idea is also simple. So public void selection sort. The idea is also simple. We have let's just take the first element, save it, and then go to the end and find the minimum element. So basically we go through the whole sequence and let's find the minimum element. We know that we need big O from M to do that, right? Just go and compare everything. Whatever is minimum, we're going to move it to the beginning, to the start. So we found the minimum, we move it to the start. And then we start again, but from the second element already. That's it. So how to implement that? We have, let's use for loop, right? So for loop, basically we start from what we call usually in selection sort left, right, index. So, and we go from left to the right. And we are going to find, to look for minimum index, right? Basically the index that contains minimum element, something like that. So let me just implement this. We start from zero, and we go to the end, like that. Now, we have the first element, left one, right? So let's introduce min I that is left. Basically, in our case, it will be 100, right? And then we are going to go through from 100 to the end, and we're going to try the minimum, to try to find the very minimum index in here. And then we're going to swap the 100 with that minimum index. Does it make sense? So for int I equals left, and we're going to go to the end. So whenever we go through this, it's important to start from left, right? So basically, because the left will be moved. Right now it's 100, then it will be this guy, then it will be this guy, then it will be this guy. So whenever we find that our current element is less than whatever was chosen here, is less than array from min I, we just assign min I to I, right? So we found the new min, the new minimum. Cool. And you just go through all numbers like that, and in the result, your min I will be the really minimum, the index of the minimum element. So after you're done with this for loop, you just swap. You swap array and you swap left with min I, right? Your 100 with whatever is founded as a minimum I. That's it, basically. Even easier than bubble sort, right? It is really important to understand all those different sortings, because those are easy sortings. We're going to cover one or two much more complicated sortings later, so it's important to understand those easy ones. I 151 I equals left plus 1. You can start from the next one, but what if your I, if your 100 is the real minimum here? You need to account that one as well, I think. So you are proposing left plus 1 here. I'm not sure, because what if your 100 will be the minimum element here? Then you need to check it as well, I would say. Let's double check it. And we did pass. There are a bunch of similar sortings. So as I promised, first of all, let me share in the Slack an amazing YouTube video for bubble sort. Just check it out. My favorite one. For those who are not in Slack, let me just even show you a couple of seconds of this. It is awesome. So it shows how the bubble sort works. This is an array of people, and they show how do you need to swap those people to achieve the result. So for those guys who did not really understand what's going on, I highly recommend this video. For others, I recommend this video as well. And I think they have the similar dances for other sorts. Shell sorts, I'm pretty sure, yeah, they can have shell sorts as well. We're not going to cover shell sort because it's kind of similar. I want to show you one more sort, different one. Again, so obviously those are, well, let's talk about the complexity, by the way. So what is a complexity here for selection sort? What is time and what is memory? Time is n squared again, absolutely. What about memory? Constant, great. So those times are, they are considered not efficient. N squared is a bad runtime complexity for algorithm. Why? Because if you're going to try to sort the array with 100 million of elements, you will need to do I don't want to count the zeros. Extremely big number, right? Because you will need to do 100 million times 100 million to achieve the number of operations. So this is really bad complexity. Right now, the most optimal sorting is n times log n, which is much better than square, but it's still a lot. We do not know how to do it in n. There is only one sorting algorithm that can do it in n, but it uses so much memory that it is not optimal at all. I will show you this algorithm though, just for you to know that there is such sorting algorithm. By the way, if bubble sort and selection sort are extremely popular, the next one, which is called counting, isn't memory getting cheaper all the time? It is getting cheaper, but let me just show you the algorithm. It is so bad in terms of memory complexity that even if it's very cheap, it's still bad. So probably you've heard about it, probably not. Counting sort. It's not very popular. Even on computer science lectures, they sometimes just skip it. But I find it really, really smart sort. So the idea is very simple as well. Counting sort. The worst thing about counting sort, you need to know the maximum value of your elements in array. Sometimes it is impossible, right? So max value, this is something this algorithm demands. And obviously there are a lot of cases when you don't know the maximum value. It can be billions, right? So I mean the maximum value of the element inside the array. So right now we have the maximum value 100, right? But sometimes it will be, I don't know, billion, and sometimes you just do not know in advance. That's a problem. But if you do know the maximum value, the algorithm is, let's just use another example. Let's just use, and by the way, it will not work. Yeah, so max and actually mean value if you're going to use negative numbers. If you're not going to use negative numbers, only max value is enough. If you're going to use negative values, then you need to know mean value as well. So let's just use, for example, positive elements with the maximum value 10, like that, 9, 5, 0, 10, 6. Then let's create the array from 0, and actually let's take for example 3 5s here, like that, right? So let's create an array with capacity of the max value. So if the max value is 10, we're going to create an array for 10 elements. And then we're going to go with a for loop through the sequence and mark how many times did we see 9. Let's say 9, then we go to the array from 9 and say 1. Then we found 5. So let's put 1 to the index 5. Then we see 0. Then let's put 1 for an index 0. Then we see 10. Then let's put 1 here. Then we see 6. Then let's put 1 to the 6th index. Then we see 5. We have 5 again, so let's just increment it 2. Then we have 5 again. Let's just increment 3. In the end, you will see something like that. You have a number of repetitions of the index as a value in the array. And then you just go through these values and you can create the array, because you see, okay, there is 1, 0. Let's put 0. There is no 1, 2, 3, 4, and then there is 3 5s. So I just put 5, 5, 5. And then there is 1, 6. Let's just put 6. And then there is no 7, no 8, and then there is 1, 9. So I just put 9. And then there is 1, 10. So I just put 10. In the result, you have the sorted array. But the price for that is extremely expensive. You need to take and save in memory the huge array that is determined by the maximum value. So if you have an array and your array basically is doesn't seem that would work if we don't have objects with a natural order. You mean if you have negative numbers or what? What do you mean natural order? So obviously, if you have negative numbers, you need to know minimum value as well. So you can start, oh yeah, even if you have negative, yeah, it's impossible to do an indexes. Yes, so basically, you're absolutely right. You should have positive numbers, 0 or anything. Yeah, 0 to infinity. That's what you need to know. Absolutely. So this algorithm has a lot of limitations. That's why it's not popular at all. Nobody uses it, but it's really cool, right? Because what is runtime complexity here? Let's double check. So, and it's really easy to implement. You need to create the let's say values. New int for max value plus 1, right? Because it can be one more. So for int I equals 0, I less than array length I plus plus, you just go and say that your values from the so your new index here will be array from I, right? So we are going through this index, through these indexes, and then we need to find the actual element here, array from I, and then take this 9 and use it as an index in our new array. And the only thing you need to do is increment it. That's it. Right? Now you need to create another one, sorted array. Sorted array. Array length. So this is just will be our new array that we're going to fill out. So we need to say, basically for int, we can reuse I here, right? I less than our values dot lengths. So we just go through our new guy, and for every single I, you need to do another 4 here, but it will be really small. Wait, so int I equals 0, iOS and values, blah, blah, blah. So now inside we have one more for loop, but this for loop is basically just, if we have 3 here, let's just reiterate through this 3 times, right? Because we need to say 5, 5, 5 at this point. So for int, let's say j equals 0, j less than what? Then actually nums, which is values from I, right? So if this is, we find 5, then we need to take value 3 and do it 3 times. So basically from 0 to 3, let's say, right? J plus plus, and we need to say sorted array from what? So basically we are here and we know that we have 1, 0. So we need to say that sorted array, we need to have one more index here. We need to have one more index here. Let's say K 0, right? And then at this point you have sorted array from K equals I equals 0. So our previous index is the new value, like that. And K plus plus should work. And actually we created a new array here, right? So this is not void anymore. We are going to return the new sorted array. Sorted array. Wow, it's actually not that trivial. You take a look at home, and I'm sure you can understand this. Complexity is an interesting thing here. Pretty cool. Internet suggests quicksort is maybe the best candidate if you're going to implement one. Haven't read many years. Easy. Comments on quicksort. So I will definitely show you quicksort because quicksort is, yes, it's the most optimal as for today. If you're going to use the built one java.sort, arrays.sort, chances are you will see the quicksort under the hood. It's actually the mix of with, if the array is huge, Java will try to do it with the quicksort, and in the end, when everything is almost sorted, it will help it with something like bubble or whatever, because there will be very few elements left, something like that. But yes, quicksort is like most used algorithm in the real world. We will take a look on it, but we need to know recursion first. So probably in 1 or 2 lectures. Okay, so let's do a unit test and you can think on the complexity. What is complexity here? It's not that easy to count. Try to do it. I will try to write counting sort. I love this accounting sort. It's so cool. And books usually omit it. Expected result is this. So let's say int actual result is sortings dot counting sort from array, and maximum will be 100 here, right? And let's expected result with actual result. Let's double check. So your thoughts on and test failed? Remove negative. Oh, yes. Thank you so much. Thank you so much. Let's just use our new array here. So the expected result will be 0, 5, 5, 5, 6, 9, 10. And the max value will be 10. Let's check it out. And test passed. Congratulations. So, thoughts on runtime complexity here? Calls, but not and, because we still have this nested for loop, right? But how to count this for loop? So the answer is, it is time. No, we don't have a logarithm here yet. So the time is big O from m plus k. What is m? What is k here? Like that. Where k, obviously n is our length of array as usual, and k, how do you think? What is this? So basically k is, at this moment, you need to go through 5 3 times. But what if all your elements are 5s, so same elements? What to do in that case? You will go through this for loop n times, basically, right? So how to count the complexity? Any guesses? No, n square is not. So should not be square here though, because actually I forgot myself. Let me double check. I remember that k is number of the maximum repetition here. So basically, if no, I don't think it's factorial. Why? N factorial times divided by n? No, I don't think so. So where k is basically the number of maximum repetitions, something like that, right? Because basically this is when the problem might occur in runtime. If you will try to do this nested for loop many times. Let me double check really quickly, because I'm not sure now. And this number, okay, is the range of input. Oh, I see now. Yes, the range of input makes sense. So basically, if it's maximum element, k is, you can say k is max element here. Why? Because, yes, of course. Whenever you go through this array, it's just an n, of course. But if you go through this array, you go through what? You go to the values dot length, right? And your values dot length is length of your new array. And what is the size of this array? Is max value. That's why. So big O from n plus k, where k is max element. Why cannot we omit the k if it's just an addition, right? We know due to mathematical analysis that we can omit it. Because we do not know which one is bigger, right? K can be much, much bigger than n. And memory is obviously big O from k, where k is maximum element. Like that. Thanks, guys.